Hi everyone, my name is Grace, and I'm part of an undergraduate group of students from Grinnell College that developed a farming game used to teach statistical concepts. Other members of our student group include Kandice Wu, who will be going through the video tutorials in our presentation, and Henry Firestone, and our mentor for the project was Professor Shonda Kuiper. Our game creates an online environment that simulates an actual farm. It's divided into seasons, and each season players can buy seeds and plant, harvest, and sell crops. At earlier seasons, the only variable to consider for the crops is water. There are varying amounts of rain each season, and players can buy additional water for their crops. The total amount of water, which includes the rain and any additional water added by the players, influences the yield for each season.
Game can be accessed from the Statue Game site under the Farmer tab. Click on Play Farmer to load the game. Before you start the game, you will need to enter player ID and the group ID. There's a tutorial option for new players, but we'll go with New Game. First, we need to plant all 6 plots. The rain comes, and we can harvest our crops. After the first few seasons, the rain level is gonna drop, so we'll need to add water to the plot in order to achieve optimal harvest. You can try different level amount of water for different plots. When we harvest the crop, we can see there is a difference between the yield. It's 9, 10, 13, and 14. When we click on the Graph tab, we can see a clear pattern between the amount of water and the amount of yield.
Students can access their data either directly in the game or they can use a Shiny app. There are a lot of statistical concepts that students can learn with this game, one of which is using data for estimation, prediction, and extrapolation. Students can use the data they collect from our game to estimate yield based on differing water levels. They can then immediately check how close they were by playing the game. Another concept that students often have trouble with is confidence intervals for regression lines. With our game, students will end up with different estimates for their models because they collected data individually and therefore have different data sets. They can learn about confidence intervals by asking if everyone ensured that water was always between 10 and 20 when playing the game, why is there variation in students' predicted values of yield, and why are there differences in the estimates for slope and correlation. Finally, another possible concept that our game can help teach is model assumptions and residual plots. In the back end, we ensure that there was some variation in yield, so there will be some outliers in the data that students collect. Students can learn how to deal with these unusual observations when creating their model. Also, since our crop models in the backend are based on quadratic models, students, especially at the intro level, can learn how to tell if a dataset seems like it belongs to a linear model or a quadratic model. When they develop a quadratic model, they can also think about how statistics relates with the real world. For example, even though their model predicts that yield will be negative with extremely large amounts of water, does this realistically make sense?
Clicking on the Data Visualization tab, we can go to a Shiny app. We can see the data from all the players that have ever played the game. We can also choose among groups or a specific player. If we color the data by crop and add a model to the data, we can see a clear pattern between different kinds of crop with water and yield.
We also just wanted to touch on some of the more advanced options for our game. So for this game, we research real yield data from farms across the United States, and each plot in our game is based on actual yields for 1/10 of an acre of land in the real world. This makes sure that the data in our game is similar to real world data. Also, as the seasons progress, we introduce some more variables such as crop types, fertilizer, pesticides, and changing cost and selling price of seeds. More advanced statistics students can take all these variables into account and create more complicated models to optimize yield or optimize profits. Since the selling price of each crop is different and the optimal amount of water or nitrogen level for each crop type is different, this game really has the potential to demonstrate how modeling can work with large data sets and several variables that affect each other.